Hi, this is Jane. In this video, we will talk about conducting an independent samples t-test using SPSS version 25. Let's get started. If you've watched our video that explains the concept of an independent samples t-test, you may recall that an independent samples t-test helps you figure out when you really do have apples and oranges in your data, where apples and oranges are different groups of people. In this example, we are going to take a look at average overall rating of the festival by gender, using two groups for gender, female and male. The overall rating question asked festival attendees, how would you rate today's event overall? Festival goers could choose an answer on a 5-point scale from poor to excellent. Here, gender is the predictor variable. We want to know if gender predicts differences in overall rating. Overall rating is our outcome variable. It is the variable that we want to learn more about. Here is the SPSS file containing the data we will use to conduct the independent samples t-test. The column marked gender contains the gender data. The column marked overall code contains the overall rating data transformed from a string or text variable into a numeric variable. To conduct an independent samples t-test using SPSS, click on Analyze, scroll down to Compare Means, and click on Independent Samples t-test. Click on Overall Code and move it to the Test Variables box. This indicates to SPSS that this is your outcome variable. Click Gender and move it to the Grouping Variable box. This lets SPSS know that this is your predictor variable. You will have to define groups in your predictor variable. Click on Define Groups. Type Male in the Group 1 box and Female in the Group 2 box. Note that you have to use the same spelling and capitalization for each category as it appears in your database. That is, if male is capitalized in your data, it must be capitalized here. If your data are numeric, you would type the appropriate number in each box. Note that you could switch the groups. That is, you could indicate that females are Group 1 and males are Group 2. The signs on the values of T and the mean difference in your output would change, but you would get the same p-value for the independent samples t-test. Click Continue and click OK. The output window is populated with the results. SPSS provides the value of T, the degrees of freedom, and 2 p-values, among other things. The t-test uses the average rating for each group and the variation in those ratings to figure out if you have apples and oranges in your data or if you really just have different kinds of apples. You're most interested in the p-value, but which one? SPSS provides a p-value for the comparison of two groups that have approximately equal variances or standard deviations, and a p-value for the comparison of two groups that have very unequal variances or standard deviations. If you have forgotten what a standard deviation is, please revisit the numeric EDA video. It is helpful to compare the standard deviations of the two groups to determine which p-value to use. As we see here, our standard deviations are fairly similar in value, and thus we will use the p-value associated with equal variances assumed. In many cases, like we see here, the two p-values are equal or very close in value. Therefore, this is often not a concern. If the p-value is less than 0.05, then that means you do have differences in your groups, apples and oranges. In more statistical terms, you use the p-value to determine if the mean of the outcome variable is significantly different between the groups in the predictor variable. For this scenario, we can see that our p-value is 0.000. This is the lowest value that SPSS provides as a p-value. While the p-value is unlikely equal to 0, this is our indication that it is very small or less than 0.05. That means that we have a significant difference in the average ratings provided by female and male attendees. Note that the p-value simply tells you if the ratings are different. It doesn't tell you which group gave the higher rating. To figure that out, we have to go back to look at the mean ratings for each group. We see that the mean overall rating for females is 4.44, which we found is significantly higher than the mean overall rating of 4.33 for males. So now what? How do you think about interpreting these results? Remember that these ratings were made on a 5-point scale where 1 was poor and 5 was excellent. Both of our average ratings were above 4.0 and so somewhere between very good and excellent on the scale. When interpreting these kinds of results, you want to think about the kinds of ratings you have overall and the group differences. So, for these results, we might say something like, Ratings for the festival were quite positive. There was a significant difference in how males and females rated the event. Males rated the festival as very good on average with a rating of 4.33. Female ratings were significantly higher and thus even closer to the top of the scale at 4.44. The default independent samples t-test in SPSS is a two-tailed test. That is, we were looking for significant differences in either direction, females greater than males or vice versa. Once we found a significant difference, we then went back to the mean for females and the mean for males to determine which was significantly greater. This is Jane signing off. Good luck and have fun!